Good morning, all. This is the second half of your volume of pyramids video. The other video just was basic, pretty basic with the formulas. Excuse me. There goes the regular yawn. Today it'll be a little bit trickier because most of the shapes that you're finding most of the pyramids that you're finding the volume of, you will have to use one of the right triangle pieces to find the height. Um, Let me just roll this down a little bit. When it comes to volume, you need the height, not the slant height. So in most of these examples, you're going to see that I'm giving you the slant height, and you have to, excuse me, pretty much create a right triangle situation. And from there, you can either use the options are going to be Pythagorean theorem. We have our specials. And we have our trig. That does not look like it says special. So we have our specials and we have the trig. So those are going to be your three things to use. Just quickly, Pythagorean theorem is your a squared plus b squared equals c squared. For your trig, the thing you need to remember is our mnemonic, that SOHCAHTOA. And then the last thing that you need to remember for this was the the specials. And the specials are the 30 60 90 and the 45 45 90. Excuse me. For the 45 45 90, it's XX and X root 2. And for the 30 60 90, the short leg is X, the long leg is X root 3, and the hypotenuse is 2X. So those are basically, for the do now, I have four different examples where we use those different methods just to try to refresh your memory. Excuse me. For the first example, there's no angles, so basically, you're probably not going to use trig, and you can't conclude that it's a special if there's no angles. So in this case, I would use Pythagorean theorem. A squared plus b squared equals c squared. Remember that the c is always the hypotenuse, so it's going to be 12 squared plus x squared equals 28 squared. 144, excuse me, plus x squared equals 28 squared is 784. So you end up with x squared equals, that's going to be 640. And then I'm going to take the square root of that. I know for some of the problems we use radical form and things of that nature. Here, sorry for yawning. Here, the factors would have, if you don't have to worry about radical form, first of all. You can always get the decimal. But if you did, here would be 8 root 10 for the radical form. And if you got the decimal, which is probably what most of us will do, it's just a little easier, you would have x equals 25.3. All right. For example 2, this is a 30, 60, 90. And for this 30, 60, 90 here, the short leg, the short leg x is 9, and the long leg is going to be 9 root 3. And again, how do you know that? That's because this is 2x. So to go backwards, you have to divide by 2 and then times root 3. For our 45, 45, 90, the legs are the same, so they're both 5, and the hypotenuse is 5 root 2. And for the last example, number 4, this one is another one where you have to use Pythagorean theorem. And this time, sorry, I don't know, these yawns just come. What's missing this time is c, so it's going to be 36 squared plus 48 squared equals x squared. All right, 36 squared. Oh, sorry. 36 squared is 1296. 48 squared is 2304. Add those together, you get 3600. And when I take the square root of that, excuse me, when I take the square root of that, I'm going to get 60. All right, so those are just to review your, refresh your memory on how we found missing parts. And now we're going to go into finding the volume of the pyramids using these right triangles. So once again, if it's a pyramid, the volume formula is going to be volume equals 1/3 capital BH. And again, that capital B is area of the base. So let's begin. So for our first example, again, these are going to be harder because it's going to be some extra work to do. Oh gosh, I can't stop the yawns right now. I'm sorry. So for this is your slant height, and that's what we're given. We're given that is 5. Now, it's not required that you separate it, but I'm just going to bring it over here just so it's clear what we're looking at. So this is 5. So this is what I'm bringing over here, this triangle. This is 5. At the bottom is x. Now, this is it's not marked congruent, but this is 6 as well as it is over here. So this is a square. So because that's a square, this height here is at the midpoint. It's at the middle of the base, excuse me. So that part at the bottom x there is going to be 3, because all the way across was 6, and if you're at the middle of that, that would be 3. And so we're looking for our height. Now, some of you might recognize this as a 3, 4, 5. It's a special. If you don't, Pythagorean Theorem, 3 squared plus h squared equals 5 squared. 9 plus h squared equals 25. H squared equals 20 is 16, I'm sorry. Square root, h is 4. All right. So then once you get your height, the rest should be pretty easy. You're just going to plug into the volume formula. Volume equals, sorry, I'm still yawning, equals the area of the base. In this case is going to be 6 times 6. It's a square. And then the height is 4. So that's going to end up being 18 times 4. And 18 times 4 is 72. All right, so our first example, the volume is 72 cubic units. All right, let's move on. Our next example, example 2, is fairly similar to example 1. So I would suggest you guys pause the video, give it a try before I show you, before I show you the answer for that one. Okay, so as I was about to finish putting up the answer here, I realized again I did not mark this, but this is a square. So I should have marked this, so these are all 14. But this is the square pyramid here. So therefore, once you get to this last step there, it's going to be 14 times 14, because it's a square base. And then the height of the prism, hopefully you figured out it was 24 as well. So it's going to be 196 times 24. I think I just, hold on, sorry, as I'm doing this, I think I took a half of this previous question. Yeah, I did. Sorry about that, Gus. I'm like, I think I took a half. I'm sorry, for this one I took half of 36, so I shouldn't have done that. It should have been a third. Sorry. Let me erase this. So it would have been 12 times that. So the answer for this one's going to be 48. Sorry. Correct me. My bad. So it's 48 centimeters cubed for that. Excuse me. All right, and that is that for number 2. For number 3, this one is a cone, and for the cone, the volume formula is pretty much the same. It's 1/3. It's the area of the base, and since the base is a circle, oh, what happens in my? And since the area of the base is the circle, it's going to be pi r squared, and then it's the height. So for this one, once again, we're given 18, which is this slant height. It's on a slant. It's not the true height. The true height is coming down the middle like this. So we have to figure out that for the volume. So, excuse me, I'll put my h here. So it's going to be 8 because 8 is the radius here. So to figure out this missing side, I'm going to use again Pythagorean Theorem. And this, oops, I wrote 12. And this here is 18. So I'll just write it a little closer so it doesn't look so far away. But that's 18, the slant height. So it's going to be 8 squared plus h squared equals 18 squared. 64 plus h squared equals 324. 324 minus 64 is 260. So h squared equals 260. I think that's 18 squared. Let me just double check. Okay, yeah. And then the square root of 260. And again, I'm not worried about radical form, so we'll just round to the nearest 10th. I get 16.1. Excuse me. That's the height. And now for the volume. So volume is going to be, plugging straight into the formula, it's going to be 1/3 pi. Again, we're going to leave anything circle related in terms of pi. The radius squared is just to save space, I'm just going to write that 64. And then it's times 16.1. Again, I'm just out of space here. So 64 times 16.1. My answer for this is going to be 343.5 pi. 343.5 pi. Alright, so I'm going to move on. Hopefully everyone's okay with those first couple of examples. Alright, for example 4, it's pretty similar to the other one, so I'm going to skip 4. I'll post that with the answers when I put up the answer key. But so give 4 a try on your own. You should be able to handle that one. Let's look at example 5. Excuse me. So example 5 is the first one where it's somewhat of a different looking figure. This will be a hexagonal pyramid. And again, we're given this here, which is, this here, which is the slant height. We can't use that for volume. We need the true height coming straight down the middle. That's what we're looking for. So this 5.5 is the apothem. So it would have been the same for this triangle. So it's 5.5 there. So essentially, I'll just resketch it over here. But this is the triangle that we're thinking about. We have a 10 here, a 5.5 here, and we need our height, true height. So we're going to do Pythagorean theorem. It's going to be a squared plus b squared equals c squared. Excuse me. 5.5 squared is 30.25. That's a 10. I don't know what that looks like, but that's 100. All right, so we subtract the 30.25. All right, we get h squared equals 69.75. Square root of that, I get 8.4. All right, so now we can find the volume. The volume is 1/3, capital B, H. So that capital B, again, means area of the base. So I can do it over here if you would like. It's 1/2 the apothem times the perimeter. So that's 1/2. The apothem is 5.5. The perimeter is going to be 42. It has 6 sides. They're all 7, so that's 42. So that's 21 times 5.5. This is 15.5. I'm sorry, 115.5. That's our area of the base. So it's going to be 1/3 times 115.5 times the height, which we just figured out was 8.4. So times 8.4 divided by 3. I get 323.4. All right, and that's example 5. All right. Um, Excuse me. Oh man, I keep yawning. I can't help it today. I'm sorry. Um, Number 6 is very similar to 5. Again, I'll post that one with the answers so you can look and try it on your own and see if you got the correct answer. But I want to practice a few different approaches. Most of the ones we've done so far were Pythagorean Theorem. For number 7, this is the first one where it's not Pythagorean Theorem. It's going to be something else. Now, hopefully it's clear to you that this would be a trig problem, because it's not a special, because it's not 30, 60, 90, or 45, 45, 90. It has to be those specific angle measurements. So since it's 40, we know it's not a special. So this is going to be where we use our katoa. Now, again, hopefully you guys kind of remember how to do this. So this is the triangle that we are focused on here. And for this triangle, this is the angle we have up top. It's 40 degrees. From 40 degrees, we acknowledge the side. So from 40, this is opposite. And this is what we need. We need this here. Let me not use H because I don't want you to think that's hypotenuse. And then this side here is our adjacent. That's what we need. So when it's O and A, that's when we use tangent. So it's going to be the tan of 40 equals opposite 24 over the adjacent. Remember, when you're solving these trig problems, I told you the most consistent way is to make a proportion, and you cross multiply to solve proportions. 24 equals A times the tan of 40. I'm solving for A, so I'm going to divide by the tan of 40. And that'll be my answer. So let me do that. 24 divided by the tan of 40. I get 28.6. Now, you're not done. That's just the apothem. The question, this whole thing is about volume. So we do still need to actually find the volume. And this is a cone. So when it's a cone, again, it's 1/3 pi r squared times the height. So our volume here is going to be 1/3. Again, we'll keep the pi sign. The radius is 24, so 24 squared. And our height is 28.6. 24 squared is 576 divided by 3 times 28.6. So my answer here is going to be 5,491.2 pi. All right, so that's the first one where it wasn't just a squared plus b squared equals c squared. All right, let's look to the next problem. And let me plug my computer in as well. Okay, computer's plugged in. All is well with all is right with the world again. So for the next problem, this one is different. It's a pentagonal pyramid, but what's missing this time is not the slant height. Every other problem, what was missing was a slant height. This time, what's missing is the actual apothem. That's what we're missing. So it's still gonna. This one's still gonna pretty much end up being a Pythagorean theorem situation. But there's going to be an extra step as well. So first thing we want to do is think about what we need. Volume is 1/3 area of the base times the height. So that capital B is going to be half the apothem times the perimeter. So I need the apothem, which I'm going to get right now using this triangle because that's the apothem x. So I'm going to do x squared plus 12 squared equals 13 squared. You can, again, avoid some steps, but you want to at least show some work when it comes to finding the missing side. Don't just plug it in and not show anything as to how you got the missing side. Obviously, unless it's a special that you don't need to show any work for. So in this case, we figure out that the apothem is 5. Now, hopefully you realize the next thing that you don't know is you don't know the actual side of the pentagon, the base. So you won't be able to find the perimeter. So this one requires us to do even more. And this comes back to our trig again. So if we go back to our work with the regular polygons, remember that you can find the central angle by doing the central angle are these, and you could find the central angle by doing 360 divided by 5. It's by the number of sides. In this case, there are 5 sides. So this angle here in the middle, my central angle for a pentagon, is going to be 72 degrees. So once I get that 72 degrees, it's easier for me to do it on this angle. Once I get that 72 degrees, the apothem comes down the middle and splits that 72 degree angle in 2 equal halves. So this angle here is 36 degrees. Again, the other half over here would have been the other 36, but we only need, one of these smaller triangles. All right, so my apothem is 5. Put that over here. And now I need to figure out, I'm going to put a y here. I need to figure out y, because that's going to help me figure out the side. So again, I need to figure out which trig this is going to be. So I have my katoa. And this one is opposite. This is adjacent. So this is tangent. So it's going to be the tan of 36 equals y over 5. Put it over 1. Y equals 5 times the tan of 36. 5, 10, 36. I get 3.6. If that's 3.6, this is also 3.6, which means that the side is going to be 7.2. Which means that my perimeter is going to be 7.2 times 5, which is 36. So I have 18 times 5. So my base has an area of 90. Again, I'm still not there yet. Now I need a volume. Volume equals 1/3 of 90 times the height, which we knew from the beginning, is 12. So 30 times 12, we get 360. All right, this would be like the hard, no, I think it can get a little harder, but pretty much almost as hard as it could get. It's where you have to do Pythag and you have to do like a whole bunch of things in one. If you see something like this on a quiz, there would probably only be one, because again, it requires a lot of stuff in one problem. All right, so we're going to do one more problem, then we'll call it a day. I guess we'll look at a hexagon. Both of these are hexagons. Actually, I guess we'll do 2 more problems because I want to do one of these composites. It doesn't really matter. They're basically the same, but I guess we'll do number 10. I don't think it matters. So we'll do number 10. So number 10 is a hexagonal prism. So we're doing volume equals 1/3 BH. So right now we don't have the area of the base and we don't have the height. So I'm going to start with figuring out the heights. Slant height was 26. So again, basically I end up with this triangle here. This is 12. That's the height. I'm going to use Pythagorean Theorem. h squared plus 144 equals 26 squared is 676. So you get h squared equals 532 square root. Okay, I'm just going to do decimals right now. And I get 23.1. Alright, so now I have the height. But now if I focus on what that capital B means, area of the base, it's half the apothem, which I do know. The apothem, actually I don't know, that's not the apothem. That's actually a radius. So I shouldn't have put that in that spot. This is actually a radius. It's because it's going from, to be more clear, it's going to a vertex. So remember, if it goes from the apothem to a vertex, that's a radius. I'm sorry, if it goes from the center to a vertex, that's a radius. This would be the apothem coming down the middle like that. So it shouldn't have been how I drew it in before. Still would have given you the same answer because the right triangle is there, but that's not your apothem. All right, so we have to figure out our apothem. We have to figure out our sides so we can do the perimeter. So I'm just going to draw it over here. And again, we'll start with the central angle. So 360 divided by 6 is 60. So all of the central angles are 60, and then they're split to 30, 60, 90 when you split that in half. This is 12. So this is going to be 6, the short leg. Actually, that's not going to be 6. This is going to be 6, the short leg. And this is going to be 6 root 3. Not drawing a scale because it obviously looks bigger than the other side, but the side is 12. So it's going to be half 6 root 3, that's the apothem. And the perimeter is going to be 12 times 6. 12 times 6 is 72. So 3 times 72 is 216 root 3. If you have the decimal, that's fine. I'm going to leave it with the radical until the end. Then I'll give you what the decimal is at the end. So it's going to be for the volume 1/3, 216 root 3. That was the area of the base. And then the height we already figured out was the 23.1. Alright, so 216 divided by 3 was 72. So 72 times 23.1. Alright, so this is my answer. Or if I have the decimal, you should have about that. Alright, so last thing we'll do is one of these composite problems together. And then I'll leave you guys to try some of these practice problems on your own and get up to snuff before the exit card and the final quiz this week. Praise God. Alright, so number 11 is a combination. So this would be considered like a composite. Just like we had the composites with the area, we can have composite figures with the volume. An idea of that would be like, when they figure out, well, I guess, no, that's not, that's area. But if, you were filling like, this could be like a box and then, excuse me, some type of cone here, you would add up those two separate volumes basically. So I'm going to start with the base here. Really doesn't matter which one I do first. And I should mark this. We're going to say this is a square. So these are all 48. So I'm going to start with the rectangular prism piece. And for that, it's going to be 48 times 48 times 18. And when I do that, oops, sorry. Try to erase that. Um, 48 times 48 times 18. I get 41,472. Okay. So that's just for this bottom part, the prism. Now we need to worry about the pyramid on top. For the pyramid on top, we know that this is 48. This is 48. And this is 25. But again, if you use the 25, you will be falling for it. And the answer is always, they always have that wrong answer on any of the standardized tests. So don't think like just because your answer's there that you're right. That's not the case at all. So this 48 is being split. When we take our little thing here across, it's going to be 24. So this is the right triangle we're looking at. It's going to be h squared give 49, and you end up getting that the height is 7. So for the volume of this, it's going to be 1/3. Area of the base is 48 times 48. And then the height is 7. All right. And then you would add these two answers together to get your final answer. So the volume is a combination of 41,472 and 16,128. Final answer. All right, so keep practicing some of these problems here. Check your answers with the key. And again, be prepared for your extra card Thursday. I'm sorry, extra card Wednesday. And your final quiz will be this Friday.